Yes, you are watching the continuation of crystal defects, which are also known as imperfection in crystalline solids. Stoichiometric defects were discussed. Impurity defect also discussed in the previous case. Impurity defect. Just we took NaCl with small amounts of SrCl2. Second example is AgCl with a small amount of cadmium chloride leads to impurity defect. And what is created? What is created? Due to this, cation vacancy is created. Cationic vacancy is created. Is resulted. Due to this, what happened to density? Yes, density is decreased. Density is decreased. Okay, dear students, other things will be continued. Yes, after completion of stoichiometric defects, impurity defects, shall move to the formula of the compound is changed due to missing of the particles, and that is known as non-stoichiometric defects, that is due to metal excess. Excess metal is here resulted. Second one is metal deficiency. Metal deficiency. Okay. In metal excess defect, observe the information first and then title. Na plus Cl minus, like this. This is NaCl crystal previously observed. This NaCl is heated with vapor of sodium metal. NaCl is heated with sodium vapor. Sodium vapor. What happened? Sodium, after vaporization, it becomes Na plus and electron. Yes. Na extra cation. See here, metal excess. And this electron, this Na plus is attracting which ion from the crystal? It is attracting. One student is outside the classroom, he is inviting one of the classmates, which is his friend. So like that, this is outside, Na plus attracting which one? 1 Cl minus from any one area. So 1 Cl minus coming out. Here what is happened? Anionic vacancy happened. This anionic vacancy leads to disturbance in electrical neutrality. Electrical neutrality, 8 Na plus and 8 Cl minus ions before there. After heating with sodium vapor, sodium is ionized to sodium ion. Electron, this sodium ion is now inviting Cl minus ion from the crystal. It is coming out. Then this unbalanced information, anionic vacancy, is occupied by unpaired electron. This anionic. This is due to this, white crystalline NaCl imparts yellow color. So a color is developed due to this arrangement, and this is known as F center. Farben is the German word, and it is described as F center. How do you define F center? Yes, German word Farbengenter. Farbengenter means color center. Yes. How is it created? Yes, it is created. Yes. Definition is like this. Anionic vacancy. This story is not created. As you can also take, if NaCl ionic solid is heated with its metal vapor, then what happened? Anionic vacancy is occupied by unpaired electron. unpaired electron. This unpaired electron is start moving, therefore some electrical properties are increased a little bit and color is also produced. Unpaired electron, anionic vacancy is occupied by an electron which imparts color, then that is called. So NaCl now gets yellow color. This is called F-centered. Metal excess due to anionic vacancy, also known as F-centered. Yes. Examples: NaCl with excess of sodium vapor. Which color is generated? This is white color. This white color solid becomes yellow color. Why yellow color? This is the answer you have. Next, lithium chloride with excess of lithium vapor. Pink color is, this is for matching purpose, useful for competitive point of view. Next, potassium chloride with the excess potassium vapor, then it becomes lilac color. Violet, lilac is violet. I hope you followed this one, useful for competitive point of view. This is when metal ionic crystal is heated with its metal vapor, then anionic vacancy is resulted. That anionic vacancy occupied by unpaired electron gives color, imparts color to the crystal. Those colors absorb. Zinc oxide is another crystal which is in a colorless condition, white. Zinc oxide is white in color under normal conditions. On heating, oxygen is escaped and it is ionized to zinc 2 plus ions and 2 electrons, and half mole oxygen is escaped. Then what is created? Extra cation is there, so it is also metal excess. These are not in vapor state. Zinc 2 plus ions which are in interaction with electrons. Electrons also not escaped from the lattice crystal, vicinity of the crystal, but oxygen is escaped. So here what happened? Extra cation is coming, and what is also resulted? Extra cation, and that is only metal. Extra cation is absorbed. This is completely removed from the site, and here zinc 2 plus ions coming back to extra as extra. Already some zinc ions are there. Zinc 2 plus extra coming, and electrons also occupying. Both are occupying at different interstitial spaces and exhibits in which color? Yellow color. In which condition? Hot condition. So zinc oxide is colorless on cold condition. On heating, it turns to yellow color. Reason is metal excess due to extra cation. And the formula of the compound also changed. That's why it is known as non-stoichiometric compound. So the compound is zinc 1 plus some Zn2 plus ions. 1 plus X plus oxygen. Therefore, formula is changed and it is known as non-stoichiometric defect, and white color zinc now becomes yellow color on heating due to extra cation coming back to the interstitial void. These two are occupying interstitial space or voids, and oxygen is completely escaped from the lattice. This is another one under metal excess defects and also a non-stoichiometric defect. Now move to metal deficiency. There are many solids difficult to prepare in stoichiometric proportions. There are many solids difficult to prepare in stoichiometric proportions, and they are nothing but metal deficiency defect. What is the example? For example, FeO is taken. Iron is here in +2 state, but some of the +2 state iron ions replaced by Fe3 plus ions, means here the metal is exhibiting variable oxidation state, and the metal atom which is here present, here less than the required amount. So FeO is existed as Fe 0.93 O1. If here Fe1 and O1, that is stoichiometry, but stoichiometry is not maintained, and that is due to exhibiting different oxidation states. Some of the Fe2 plus ions are replaced by Fe3 plus ions, and metal atoms are present less than the required amount. Such compounds exhibit a defect known as non-stoichiometric defect known as metal deficiency defect. That is by transition and inner transition elements exhibit compounds or form compounds without maintaining stoichiometric proportions due to variable oxidation states. That is another one known as metal deficiency defect. Yes, observe dear students, the metal here present, less amount of metal present than the required amount in the given solid is known as metal deficiency defect. Why it is resulted is your doubt. That is clarified by exhibiting the property of metal of the compound variable oxidation state. So Fe is not in fixed quantities, sometimes 0.93 oxygen 1, sometimes 0.94, 95, 0.96 oxygen 1. But oxygen is 1. Sufficient amount of iron is not available. Such compounds exhibit a non-stoichiometric defect is known as metal deficiency defect. We will do some problems on this one. Observe the problem, dear students. Analysis shows that nickel oxide has formula Ni 0.9801. One written or not written, not at all a problem. So here the metal is not present, or less amount of metal is present than the required amount is non-stoichiometric metal deficiency defect. One fraction of nickel exists as nickel 2 plus and nickel 3 plus. And solution is going in this way. Observe. Let the number of Ni2 plus ions. You can also take Ni3 plus, either Ni3 plus or Ni2 plus. How many number? We don't know. Let X. Then as here nickel is existed in a nickel 2 plus and nickel 3 plus. Both are collectively with 0.98. Therefore, then the number of Ni3 plus ions, mathematically you have to apply some mathematics here. Both are available with 0.9. One is X, other one is X minus this one. So X minus 0.98 is possible with mathematics, dear students. Then a crucial information: total positive charge on cation is equal to total negative charge on anion. Total positive charge. For understanding, it is not required to write total positive charge on cation should be equal to total charge on anion. What is anion here? The anion is O2 minus. Minus plus, that is not required. Unities are taken, quantity of the charge. So here oxygen, that is 2. and into 1. And here nickel, or for understanding purpose, I would like to write with the details. Number of Ni2 plus into charge plus number of Ni3 plus into its charge is equal to number of oxygen atoms into charge. I hope you follow this one. This is for understanding purpose, dear students. If you are strong, very easy to catch. Nickel 2 plus ions, let X into charge is 2 units, and nickel 3 plus number is 0.x minus 0.98, as the charge is 3 units, is equal to number of oxygens 1 into 2. I hope you follow. Then after simplification, 2x is equal to 2x plus 3x minus, sorry, it's a big mistake done by me. This is 0.98 minus x, 0.98 minus x into 3, then 3 8s are 24, 27, 29, 2.94 minus 3x is equal to 2. After this, solving x is equal to how much? You solve yourself, dear students. I will give you the answer. Yes, I got the x value 0.94. You check yourself whether it is correct or not. After this, come to another part, that is fraction of nickel 2 plus ions and nickel 3 plus ions. Percentage of nickel 2 plus ions, how much? As nickel 2 plus, x is nickel 2 plus 0.94 by total 0.98 into 100. Second one, percent of nickel 3 plus is equal to 0.04 by 0.98 into 100. As you are very good in mathematics, the final answer is to be copied from here, that is 95.92. 95.92. This is 4.08. I hope you followed this model, and one more problem will be solved with your great cooperation. The formula of iron oxide is Fe 0.95 oxygen 1. What is the fraction of Fe3 plus ions present in this compound? Yes. Let the number of Fe3 present. Here iron is existed in Fe2 plus as well as Fe3 plus. That is the primary idea should be developed. Number of Fe3 plus ends mathematically x, both Fe2 plus and Fe3 plus equal to 0.95. Therefore, then number of Fe2 plus ions is equal to 0.95 minus x. Now, total positive charge is equal to total negative charge. Therefore, iron 3 into x number plus 2 into 0.95 minus x is equal to 1 into 2. This 3 is the number of Fe3 plus ions into, 3 is the charge into number of Fe3 plus ions. I would like to write like this. Charge 2 units, 1 oxygen. No problem at all. 3 number of Fe3 plus ion, 3 units of charge in Fe3 plus ion into X number, 2 units in Fe2 plus ion with the number 0.95 minus X, and 2 units of negative charge of 1 oxygen. Then after 3X plus 1.90 minus 2X is equal to 2. X is equal to 2 minus 1.90, that is 0.1. I am sorry. 0.1. The calculation is wrong. 2 5s are 10, 2 9s are 18, 19, 1.90. 3x minus 2x, x is equal to this 2 minus 1.90. 1.90 becomes 0.1 x value. Yes, now fraction of Fe3 plus ions is equal to Fe3 plus ions number of Fe3 plus ions by total ions. Fe3 plus ions 0.1 by 0.95 into 100. You will get the answer as percentage fraction. That how much calculation that you do yourself. One more problem will be taken in a different way. Now the answer is, it is 1.52% of Fe3 plus 2 ions are present after calculation. To conclude this video, this is another problem to you. If NaCl is doped means adding doped with 10 to the power minus 3 more percent of strontium chloride, what is the concentration of cation vacancies? Yes, NaCl, Na plus Cl minus, Na plus Cl minus. Correct? What Sr2 plus is coming? So one vacant, Sr2 plus is occupied, but electrical neutrality is disturbed. That's why equal number of. Therefore, number of cation vacancies is equal to number of SrCl2. Okay, I hope you followed this one. Then based on this idea, take that one, that is how much? 10 to the power minus 3 more percent by 100. More percent. That is equal to 10 to the power minus 3 by 100. That is equal to 10 to the power minus 5 moles of concentration as R. Total number of cation vacancies, concentration is equal to 10 to the power 5 moles into Avogadro number, 6 into 10 to the power 6.022 into 10 to the power 23 answer. I am sorry, this is minus 5. This is minus 5. Then 6.022 into 10 to the power of 18. That is end of the story. Have a nice day. Good luck.